is problem number 3 from chapter 17. We want to determine the moment of inertia of the thin ring about the z-axis. The ring has a mass of m. Now, in this problem, we get to use one of Professor Moore's favorite tricks. So we're looking for the moment of inertia about the z-axis, which is coming out of the page. But notice that all the mass is at the same distance from the z-axis. So we can actually use here equation 17(1) and say the moment of inertia is equal to the integral of r squared dm, but in this case, r squared is always capital R squared since all of the mass is at a distance, capital R. So we can say that is r squared over dm, and capital R is a constant, so it can come outside of the integral. And when you integrate all the mass, you get the total mass, which is m. So this is r squared m. And that is the moment of inertia about the z-axis for the thin ring. And we looked at this before, but you can check in the back of the book, and that is the moment of inertia about the z-axis for the thin ring. Since that problem was so quick, let us look at a similar situation from Physics 261. When you want to calculate the electric potential, you have K dq over R. If you were going to calculate the potential at this point here for a thin ring that has a total charge Q and the radius of the thin ring is R. Once again, little r is always equal to capital R since all of the charge is at the same distance from our point of interest here. So you can pull the K outside, you can pull the R outside, and then you just have dq. Rather than expressing dq in terms of R by using a charge density, you can just add up all the charge that you have, which gives you capital Q, and we get KQ over R, which is the correct potential at the center here. So whenever you have little r as a constant, which can come outside the integral, you don't have to integrate with respect to x, y, z, or r. You can just integrate with respect to m, and that gives you your moment of inertia. But this only works in special cases when little r is actually constant. But if you do have such a case, then you can use this little trick.